Now let's step down from the lofty heights of higher order programming and go to a more humble idea, which is the notion of a record. So a record is more modest than a higher order, but it's still important, and it is important for symbolic programming, and it's important to assist for data abstraction. It makes things much more readable, and it lets you do symbolic calculations. So it's still something important. Also, a record is going to be a compound data type. So records are, in some sense, the general compound data type. And we will build the other compound data types using records. And to explain records, let's introduce first an even simpler type called the atom. So an atom is a symbolic value or constant. So basically, it's a sequence of lowercase letters and digits, and it has to start with a letter in Oz, so that there's no ambiguity. Notice that it's lowercase because higher case is used for identifiers. If you want to use other characters such as uppercase or punctuation marks or whatever, then you have to delimit the atom by single quotes. So here's an example of a list containing 5 atoms. The list L contains the atoms John, Paul, George, Ringo, and this funny atom with numbers, vertical bar, star, and less than symbols delimited by the single quotes. So browse of L.1 will return the first element, which is John. Browse of L.2.1 will return the second element, which is Paul. And browse of length L, which will return the length 5. So you can use atoms in calculations. You can compare them, put them in data structures, print them out, and so on. So it's a staple of symbolic programming. So now let's go to records. So a record groups a set of values into a single compound value. So a record has a fixed number of values, and you can access them directly. The way it works is that the record has several pieces. It has a label, which is basically an atom. It has then a set of pairs of a field name and each time its corresponding field. So like I said, a label is an atom. Field names are atoms or integers, and the fields can be any value. And the field names and the fields are separated by a colon mark. So the position of a field is not important. So if I have the record point x colon 10, y colon 20, and point y colon 20, x colon 10, both of these will group the two values, and they're in fact identical. If you compare them using equal, equal, it will say true. So the order is not important. On the other hand, all field names must be different. If I have the record box in colon dead cat in colon live cat, where dead cat and live cat are atoms, this is illegal because I am using twice the same name, field name in, but I can say box in colon cat and alive colon x, where x is some identifier, and that's legal. So here's an example record with 5 fields: rectangle, bottom colon 10, left colon 20, top colon 100, right colon 200, and color colon red, with atoms and integers. So what kind of operations can you do in records? In fact, there are very many of them. You can create them dynamically. You can do very many complex calculations with the records. There is the record module in the system. I'm not going to talk about that now. That is kind of out of the scope of the course. I will talk about the basic important operations that we will use. So I will use the following record: rectangle, bottom 10, left 20, top 100, right 200. So the first and most basic operation is the dot operation. This lets us access the fields of a record. So for example, r.top minus r.bottom, and r.right minus r.left, and then we do calculation. And notice top and bottom and left and right, they don't have to be known in the text of the program. They can be atoms that are calculated or returned as results of functions, and so on. Also, the label and fields of a record, we can extract them directly, so the record knows about itself. So label of R will return the atom rectangle. Width of R will return the number 4. There are 4 fields in this rectangle R. And arity of R returns a list a list of the field names in alphabetical or technically lexicographic order, bottom, left, right, top. So records can be used in all kinds of calculations. For example, comparison, R equal rectangle. And here I have a record where I've changed the order of the fields, but it doesn't matter. The order is unimportant, so it displays true. I can also use them in pattern matching. Case R of rectangle, bottom A, top B, left C, right D. This matches and it gives the corresponding values to the identifiers A, B, C, and D. So records are the only compound data type in the kernel language. So for simplicity, the kernel language contains only records. And other data types are encoded or are particular forms of records. So for example, the atom can be seen as a record whose width is 0. There are no field names. A tuple is a special case of a record whose field names are successive integers starting with 1. So for example, 1, 2, 3, 4. If the numbering condition is not satisfied, if I have, for example, the fields 1, 2, 3, 5, then it's not a tuple, but it's still a record. And if I write a syntax and I don't put the fields in, they're automatically numbered starting from 1. So if I do pair HT, it's just a syntactic sugar for pair 1 colon H 2 colon T. Okay, so that's tuples. A list, which we have seen already as a recursive data type, it's built with the two records nil and H bar T. Notice H bar T is syntactic sugar for a bar H T. The bar here has to be enclosed in quotes because otherwise there would be a confusion between the bar used infix in between the two arguments. And finally, this is the same as the full record notation, quote, bar, quote, open parenthesis, 1 colon H, 2 colon T, close parenthesis. So using only records in the kernel language keeps the kernel language simple. A single compound data type suffices to understand the execution of programs, and all other types are encoded with records. So let me now give some examples to finish this video. For the following records, the question is, are they tuples or lists? So for example, here, the record little a, 1 colon A, 2 colon B, 3 colon C. Is it a tuple or a list? Does it satisfy the condition of a tuple or of a list? Well, the field names are successive integers, 1, 2, and 3, so this one is in fact a tuple. Okay? What about B, which is the record A, 1 colon A, 2 colon B, 4 colon C? Well, this is not a tuple because their integers are not consecutive. What about C, 0 colon A, 1 colon B, 2 colon C? Well, this is not a tuple either because the integers don't start with 1, they start with 0. What about 1 colon A, 2 colon B, 3 colon C, and D, where I don't give a field name? Remember, the field names without, the fields without field names are numbering starting with 1. And here that means I have two fields with a 1 here, so this is an illegal syntax. Okay? What about E, where I have A, 2 colon B, 3 colon C, and 4 colon D? Well, the A implicitly is numbered 1. It is the first field without a field name. So in all, I have consecutive numbers starting from 1. So this is a tuple. Okay. What about F? 2 colon B, 3 colon C, 4 colon D, A. Well, the A is still the first field without a name. It's still starting the numbering with 1, and the order is not important, so this is a tuple. Okay? What about G? 1 colon A, 2 colon B, 3 colon C, foo colon D. Well, all the fields are not integers, so this is not a tuple, it's just a record. What about H, which is vertical bar, 1 colon A, 2 colon vertical bar, 1 colon B, 2 colon nil. Actually, if you look carefully, this satisfies the definition of a list. So this is in fact a list. What about I? Vertical bar, 1 colon A, 2 colon, and then vertical bar, 1 colon B, 3 colon nil. Well, here we have a 1 and a 3. It's not a 1 and a 2, so it's not a list. This is a nested record.